Taking a look at 7.7. 7.7 takes what we've done with our trig function so far and takes it one step further. So far, we've talked about that SOHCAHTOA and working with it and using it to find our missing sides of our triangle. 7.7 takes that, though, and it moves it one step further. So in our opener here, it says find the sine of angle A. So we've already done those types of problems. If we look at the sine of angle A, sine is our SOH. So the sine of angle A will be the opposite side over the hypotenuse. So opposite of angle A is 3. The hypotenuse is 6. Right? So 3 over 6, if we wanted to, we could say the sine of angle A is 1/2. That's 3 over 6. Or 0.5 if you wanted to put it as a decimal. In the opener, that's all that they ask us to do. And so far, that's all we've known how to do. What 7.7 does is it says, okay, this is an equation. It has a variable in it. Our variable is this angle A. We can actually solve this equation for angle A. All operations have an inverse function to them. Right? When we have the equation 2x equals 10, we said, well, to solve for x, we divide both sides by 2, because that was the opposite of multiplying. When we had x plus 5 equals 10, we said the opposite of adding 5 is we'll have to subtract 5 from both sides. Even when we had x squared equals 25, squaring something, that squared part has an inverse operation to it. It was taking the square root of each side. So that x equals 5. Sine, cosine, and tangent, they are no different. They have an inverse function to them also. Right? So to solve this equation, we're going to take what they call the sine inverse of each side. The sine inverse, it is just a sine and has a little -1 to it. Sine, -1. A sine inverse and a sine, they cancel each other out. Just like the times 2 and divided by 2. +5, -5. The x squared and the square root. Those things all cancel each other out. It is no different here. We are going to cancel out that sine of angle A. What you do to one side, you have to do to the other. So I'm going to take the sine inverse of 1/2. Once again, this is where you need your calculator. Right? On my calculator, if I look right above the sine, cosine, and tangent buttons, there's a little SIN -1, COS -1, TAN -1. Those are your inverse functions. So we want the sine inverse of 1/2. And I hit enter. It gives me 30. That tells me the measurement of angle A is actually 30 degrees. Each of my trig functions have that inverse operation to it. Your sine has one. Tangent has one. If the tangent of angle A equals some value, then I take the tangent inverse of that value to find the measure of angle A. If the sine of angle A equals some value, then I take the sine inverse to equal angle A. And same thing with cosine then. If the cosine of my angle equals some value, I take the cosine inverse of that value to find the measurement of angle A. Okay. In our next example, it says use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So here's angle A. So this is opposite. This is our hypotenuse. This is the adjacent leg. So to do, if I'm working with angle A, If I want to do opposite and adjacent, that is my O and the A. So I need to do TOA. That is our tangent value. So I'm doing the tangent of angle A equals 16 was opposite, 20 was adjacent. So I need to take the tangent inverse of both sides. We get angle A will equal that tangent inverse of 16 over 20. Once again, this is where you just need your calculator. We're going to do second tangent of 16 divided by 20. We get 38.66 degrees. Right. Looking at your next example there. It says let angle A and angle B be acute angles in two different right triangles. Use the calculator to approximate the measures of angle A and angle B. So this is just practicing using that calculator. We want to take for the first one that sine inverse of both sides. So we're going to take the sine inverse of 0.76. And we get 49.46 degrees. For the second one, we're going to do the cosine inverse of both sides. So these cancel out, and angle B will be the cosine inverse of 0.17. We get 80.21 degrees. All right, the last new thing to go over here talks about just a different set of directions. The directions here say to solve the right triangle. To solve a right triangle means to find all missing pieces. So to solve our triangle here, we need to find the value of angle B. We need to find the length of BC. We need to find the length of AC. Let's start with angle B. The three angles of your triangle must add to 180. So I can do 23 degrees plus 90 degrees plus x equals 180. 90 and 23, when you add them together, we get 113. And then we'll subtract that 113 over. And we get 67 degrees. So there is one of our missing pieces. Now, to find y, if I want to be at my 23 degrees, for example, this is my hypotenuse, this is my opposite leg, this is my adjacent leg. So if I want to find y, I can do opposite and hypotenuse. That's our O and our H. So that is our SO from SOHCAHTOA. The sine of my angle, sine of 23 degrees, equals opposite was y, hypotenuse was 40. Now, sine of 23, this is not the sine inverse of 23. This is the sine of 23 degrees. So this is just the plain old normal sine that we were doing in the last two lessons. So sine of 23, we get 0.3907. We'll throw it over 1 equals y over 40, and we cross multiply. 1 times y is y. 0.3907 times 40. We get y to equal 15.63. We still need to find z. So if I wanted to find z, we now have the adjacent and the hypotenuse. That is the A and the H. That is our ka from SOHCAHTOA. So I can do the cosine of 23 equals adjacent is Z, hypotenuse is 40. Cosine of 23, once again, it is just a number. Cosine 23, it is 0.9205. We'll throw it over 1 equals Z over 40, and we cross multiply. 1 times Z is Z. 0.9205 times 40 is 36.82. So there's our value for Z. There's our value for Y. There's angle B, or our value for X. All right, last problem here. It says you're building a track for a model train. You want the track to incline from the first level to the second level, 4 inches higher over a span of 96 inches. It says, is the angle of elevation less than 3 degrees? So we need to find the measurement of our angle X here. This is our hypotenuse. This becomes the opposite leg. This becomes the adjacent leg. So the values I'm working with are opposite and adjacent. That is O and A. Opposite over adjacent, O and A, that is our tangent. So it is the tangent of my angle. The tangent of X equals the opposite is 4, the adjacent is 96. To solve my equation, this is where we have to get rid of that tangent to get to my X. So we must take the tangent inverse of each side. This is where we're going to use that inverse feature. These go away, so I have X equals whatever the tangent inverse of 4 over 96 is. So that's what we need to evaluate there. Second tangent of 4 divided by 96. And we get 2.39. So to answer the question, is it under 3 degrees? Yes, it is. Which brings you to your homework tonight. Pages 485 to 487, numbers 3 to 8, and 10 to 18. Please email me. Let me know if you have any questions.